Dear students, we are going to see what is meant by electronic transition. So depending on the spin of electrons, the electronic transitions are differentiated into singlet state and triplet state. Now see what is meant by singlet state. A molecule in which all spins are paired is called as singlet state. A molecule in which all spins are paired. Now see here. So this is the spin of electron. The spin is up is in upward direction. The other spin of electron is in downward direction. So the spins are paired. Therefore, this state is known as an singlet state. What is meant by triplet state then? A molecule in which two unpaired electrons have same spin, means two unpaired electrons. So this one is unpaired. Second one is also the unpaired electrons. So these two unpaired electrons have a same spin. Then such pairing of electron, the state of that electrons is known as an triplet state. So depending upon the spin of electrons, the electronic transitions are of singlet state and triplet state. Now the next in that, what is meant by spin multiplicity? So the spin multiplicity is equal to 2s plus 1. 2s plus 1. So what is meant by s? So s is nothing but the total spin of electrons. So the electrons which are present in the molecule, if we add the spin of these electrons, we are getting the spin multiplicity. So spin multiplicity is nothing but addition of spin of electrons. So what it decides? It decides the electronic states, whether the given compound or whether the molecule is in singlet state or triplet state is decided by the spin multiplicity, that is by this equation 2s plus 1. Now see here, if suppose in a molecule, if all electrons are paired after the excitation, then what happens? So this is a pairing. Okay, if all electrons are paired, then total spin will be 0. Total spin will be 0. Why? Now see here, the spin of single electron is plus half. The spin of second electron, which is in opposite direction, is of minus half. If you add this plus half and minus half, we have a 0 value. Then the total spin will be 0 for the paired electron. Now if you put this 0 into this equation, that is 2s plus 1 equation, then 2 into 0 plus 1, so 2 into 0, 0 plus 1, that is we are getting the value of 1, means the spin multiplicity of a molecule will become 1 if all the electrons are paired. So that state is known as an singlet state. So just above we have seen what is singlet state? A molecule in which all spins are paired, means if the electrons are spin paired, the spin multiplicity is always 1 and the molecule is in singlet state. So this S0, S1, S2 are the ground state and different excited singlet states. So S1, S2 are the excited singlet states and S0 is a ground state singlet state. So this is what if electrons are paired. If suppose the electrons are unpaired, like this one, if these two electrons are unpaired, so both the heads are on upward direction, means these are not in pairing. If all these electrons are unpaired, means the spin of this electron is plus half. It is also in the upward direction. This is also plus half. If you add these two, plus half and plus half, it becomes equal to 1, means the total spin will becomes 1 and the spin multiplicity now 2s plus 1. Put the value of s is equal to 1. 2 into 1 is equal to 2 plus 1, means total is equal to 3. Now we are getting, that is the spin multiplicity of an unpaired electron is 3. Therefore what is it indicates? It indicates that it is a triplet state. If the total spin will be 0, by putting the value of 0 into s plus 1, then we are getting the value is equal to 1, that is the spin multiplicity is 1 and it is in a singlet state. if it is unpaired, the total spin plus half is equal to 1, and by putting the value of 1 in this equation, that is 2s plus 1 equation, we are getting 3 as a spin multiplicity value, and that 3 is nothing but it is the triplet state. So this T0, T1, T2 are nothing but corresponds to a ground state and excited state of that molecule. So this is nothing but the spin multiplicity. Now see here, for every excited singlet state, that is for every excited singlet state S1, there is a corresponding triplet state. Means if molecule is undergoing excitation by absorbing radiation, then it goes from lower energy to higher energy. If suppose it is in the higher excited state, that is singlet state, then it also corresponds to a triplet state. Means there is a triplet state also present. This triplet state has lower energy than the corresponding singlet state. Means energy of singlet state is more than the energy of triplet. Suppose we put this S1, this is the total ground state. If electron is excited from lower energy to higher energy S1 state, this one is the triplet. Means the T1 has, that is triplet state, has lower energy than the singlet state. So this triplet state has lower energy than the corresponding singlet. Now see here, what is the lifetime difference between the singlet and triplet? The lifetime of a triplet state is about only 10 raised to minus 5 to 10 raised to minus 3 seconds. So within a fraction of a second, the electrons from the triplet state comes to the lower energy state, that is ground state, by emitting energy or by giving energy to other electrons. This triplet state is paramagnetic because the electrons are not paired, while the singlet state is a diamagnetic. Singlet state is diamagnetic because in a singlet state the electrons are always paired. So now see here, so we have seen what is meant by electronic transitions, what is meant by spin multiplicity. Now we are going to see what is meant by allowed and forbidden transitions. So what is meant by allowed and what is meant by forbidden? So this is also important for the discussion. The electronic transition are governed by the selection rules. Means there are some different rules which are governed by the selection rule to explain the different transitions as an allowed, forbidden, whether it is a singlet or triplet. So now see here, so what it explains, what it tells us, the selection rule tells, according to this rule, during electronic transition, now see here, according to this rule, during electronic transition there will be no change of spin, that is the spin multiplicity remains the same. Means whether the molecule absorbs energy, the electron from lower energy to higher energy, that is excitation of electron takes place from lower energy to higher energy, but during this electronic excitation, according to this rule, there is no change in the spin. If the electrons in the ground state are paired, if it is ground state, suppose ground state G, when it absorbs energy in the higher energy state, the electronic spin remains the same. Either this electron is excited here or this electron is excited, that is the spin of electron remains the same. So this is given by the selection rule. Means if the molecule is excited from singlet state, it should go to only S1 or S2, that is the spin of electron does not changes according to the selection rule. If now see here, on the basis of this selection rule, the electronic transitions are classified into two types. So as per this rule and electronic transitions, there are two types of transitions. One is allowed and one is forbidden. Second one is forbidden. So now what is meant by allowed and what is meant by forbidden? Now see here, electronic transitions involving the same multiplicity state, that is what we say here, there is spin multiplicity. Okay, if the spin multiplicity of these excited electrons, if it is same, then that electronic transition is known as an allowed transition. So that is known as an allowed transition. So what is meant by allowed transition? In allowed transition, the spin of electron does not changes. Means if electrons in the ground state are in S0, they must excited to the next higher energy state, which is singlet, not in a triplet state. So singlet to singlet or triplet. In singlet state, we know that in singlet state, if electrons are paired, then the spin of one electron is plus half, the spin of second electron is minus half. If we add these two spins, it becomes 0, and if we put this value of 0 into this spin multiplicity equation as total spin, if we put S is equal to 0, then 2 into 0 plus 1, it becomes 1, means the spin of electron is in a singlet state, means here is also 1, here is also 1 spin multiplicity. So singlet to singlet excitation is an allowed transition. Triplet to triplet means 3 to 3 is also a allowed transition. But those transitions involving different multiplicity states, if there is a change in the spin multiplicity state, then that transition is known as an forbidden transition. For example, singlet to triplet or triplet to singlet. So that transition of electron from one multiplicity state to another is known as an forbidden transition. So the next one is, so you may know what is mean by electronic transitions, in that there are two states, singlet and triplet, depending upon the spin of electron, whether these are paired or unpaired. Depending upon that, we may call as singlet state, or we may call as an triplet state. So the second point is spin multiplicity, 2s plus 1. By putting the value of s, that is spin of electron, the total spin multiplicity we will get. So according to that spin multiplicity, there are two states, that is singlet and triplet state. If electrons are paired, then that state is singlet state. If electrons are unpaired, then that state is a triplet state. So the next rule is a selection rule. So by using the selection rule, we can govern the electronic transition as an allowed and forbidden transition. So in allowed transition, if electrons are excited from lower energy to higher energy in the same multiplicity state, then that same multiplicity state transition is known as an allowed. If there is a change in multiplicity state, that is known as an forbidden. If S to S or T to T, that transition is known as an allowed transition because it is allowed, and forbidden transition is nothing but there is a change in the spin multiplicity, that singlet state to triplet, that is S to T or T to S, that is spin of electron is get changed.